What I want to talk about now is I want to talk about section 4.6, which is the other trig functions besides sine and cos. So there are 4 other ones. So the first thing we're going to look at is we are going to look at y is equal to cosecant x. Cosecant is the reciprocal of sine. So in order to graph cosecant x, first we have to graph y is equal to sine x. First we have to graph that. So if we do this, and with graph paper I can be very accurate. So 30, 60, 90, 30, 60, 180. So do 270 and 360. So I can be really accurate. And what I've done is I've made every square worth 30 degrees, right? 30, 60, 90, 120, 150, 180, and so on. I'm going to go every second square is 1 on the y-axis, just so you can see a little bit of what's happening. So if I graph y is equal to sine x, sine of 0 is 0, sine of 90 is 1, 180 is 0, 270 is negative 1, and 360 is 0. So when I graph this, now that I'm using graph paper, it should be really nice. Looks about the same as when I don't use graph paper, but anyway. Now, if I want to graph cosecant, we're going to do that in purple. If I want to graph cosecant, cosecant is the reciprocal of sine. So I use all those reciprocal rules that I know from graphing other functions like parabolas. One of them is that wherever the graph touches or crosses the x-axis, I have a vertical asymptote. So I have a vertical asymptote at 0, I have one at 180, and I have one at 360. The other thing is the reciprocal of 1 is 1. So this would be an invariant point. The reciprocal of negative 1 is also negative 1. So this would be an invariant point. And then whatever is above the x-axis, which is everything between this asymptote and this asymptote, whatever's above the x-axis is still going to be above the x-axis, but it'll be going in the opposite direction. So instead of like this hill, it's going to be going this way. And the same thing on this side. Instead of being like a U shape, it'll be this, never crossing your asymptotes. And that's it. That's a cosecant graph. Doing a secant graph would be exactly the same. Would be no different at all. And so, again, if I were to draw y is equal to cos x, and again, I would use the same scale. So, well, that was really crooked. 30, 60, 90 to 180 to 1 to 270, 1 to 360. And if we say here's 1, 1, 2, here's negative 1. So if this was a cos graph, it would look like this right here. And it looked like that, right? So not really good there, but anyway. Now, if I was asked to draw the reciprocal, which would be y is equal to secant x. Same rules as before. Wherever it crosses the x-axis, there is a vertical asymptote. Wherever it's 1 or -1, I have an invariant point. And so this is headed down, so the reciprocal is going to head up. Now it would keep going, so I would have the other half of the u on the other side. Over here, it would head down on either side, and here it would head up. And again, if I kept going, there'd be another asymptote over here, and this would go up like that, right? That's it. Now, we discussed this in class, but if I give you an equation and I ask you to graph it, you are always going to want to draw. Well, let me explain just a sec. So if I were to give you, and I'm just going to make it up because there isn't really one in the textbook, so I'm going to make it up. If I were to give you y is equal to, let's say, 3 secant 1/2 x minus 30 degrees, let's say minus 2. All right. So let's say that's what I was going to do. Now, I got to get this on here just a sec. Woo, all the way to the end. So 30, 60, 90, 1, 8, 1, 2, 180, 1, 2, 270, 1, 2, 360, 1, 2, 450, 1, whoops, that was wrong. I think, yeah, 1, 2, right there. So 1, 2, 450, 30, 60, and that would be 540. And then you could keep going. I'm going to only be able to go that far because my page only goes that far, but that's cool. So this time, because of what the amplitude is 3, and I have a limited amount of space, I'm going to go 1, 2, 3, and I'm going to go -1, -2, -3, and so on. So even though it's secant, I'm actually going to draw first. I'm going to draw, let's do green. I'm going to draw y is equal to 3, because I can do that right away. I'm going to do 3, and secant is the reciprocal of cos. And I might even do the 1/2 part with it, because the 3 means I'm going to multiply my y values, and the 1/2 means I'm going to divide my x values. I can do that all at once. If you need to do it in more than one step, do it in more than one step. So normally, if I'm doing cos, cos of 0 would be 1, but we're going to multiply it by 3. And we're going to divide the x value of 0 by 1/2. Still 0. Now, at 90, it's usually 0. We're going to multiply the y value by 3. So 0 times 3 is still 0. But we're going to divide the x value by 1/2, which would bring me to 180. So that's going to go here. Now, normally at 180, I would do cos of 180, which would give me -1. But now it's going to give me -3, and I'm going to divide it by 1/2, which is going to bring me way out here. So then at 270, I would normally do cos of 270, which would be 0. So 0 times 3 is still 0, but we have to divide the x value by 1/2, which is going to bring me to 540. Now I'm not going to have space to do the last bit, but normally at 360 it would be 1, so we'd move it up to 3. We'd multiply that by 2 or divide it by 1/2, which would bring us to 720, which is out here, and I can't do that. So I'm not going to get one full wave. On your page, I would expect you to draw one full wave, okay? I would expect you to keep going and draw one full wave. Now, I'm going to keep going. This minus 30 would move all my points to the right 30 degrees, so 1 square, and down 2. So I'm going to go right 1 square and down 2. I'm going to go right 1 square and down 2. I'm going to go right 1 square and down 2. I'm going to go right 1 square and down 2. Now again, I would expect you to have one full wave. I don't have the space to do that. That's okay. So kind of just going to do this. And again, the max would be at 1, and it would kind of head down from there, right? And this would keep going up. All right, so the purple line is almost, that's kind of handy. The purple line is almost, oh, I didn't want to get rid of that line. Okay, the purple line is almost my answer, just not quite. So here. So I'm going to do my final in blue. So again, the same rules apply. Wherever this crosses the x-axis, you're going to have an asymptote. So I would have one here, approximately. And if this kept going, let's say I would have another one here. Let's go with that. All right. Now, on this side of the asymptote, there's a 1 here. The reciprocal is 1. It's headed down, which means the other side, the reciprocal is headed up. Now, in between the two asymptotes, wherever the graph is at -1, so like here and like here, you have an invariant point. Now here, the graph is at -5, right? Because it was -3 and I moved it down 2. So it's actually at -5. The reciprocal of -5 is -1/5. So that's actually going to be like here somewhere, really close to 0. So because this is a U shape headed up, the reciprocal is going to be headed down, but you have to make sure you go through those invariant points. So it's going to be like this super wide, funky, upside down U shape. And that's it. So draw it all as if it's cos first. Do all the transformations to cos. And then the very last thing you do is the fact that it's secant, and you do the reciprocal. All right, I only have to show you one more thing, just one. And that is tan and its reciprocal. And I'm not actually going to get you to graph a whole lot with tan. I just need you to see what it looks like and kind of be able to identify things about it. But we're not going to do a whole lot of big transformations to it. So here we have this wonderful thing that I cannot, why can I not do a straight line? It's a problem. Okay. So 30, 60, 90, and 1, 2, 180, 1, 2, 270, 1, 2, 360, and you could keep going if you wanted to, but 360 is far enough. And here is 0. So if we decide that we're going to graph y is equal to tan x, let's do that in a color. Let's do that in red. Okay, so we're going to do tan x in red. If you put into your calculator tan of 0, it tells you 0. If you put in tan of 90, it tells you undefined or error, depending on what your calculator says, but it all means the same thing. It means there's going to be an asymptote there. Tan of 180 works out to be 0. Tan of 270 turns out to be undefined, and tan of 360 works out to be 0. The problem with this isn't a graph. There's no picture. So we need to kind of fill in some space here. So if I check halfway in between at 45, it tells me that tan of 45 is 1. And we always want to know what's happening close to an asymptote. So I'm going to pick something just on this side. I'm going to pick like 89. Tan of 89 turns out to be like 57 point something. So it's way up here. Tan of 91 turns out to be negative 57. So it's headed way down there. And if I do tan of 135, which is halfway between 90 and 180, it gives me negative 1. So it's going this way. If you keep that up, if you go halfway in between 180 and 270, you get 1. If you do something close to 270, like 269, you get 57. You should be starting to see a pattern emerge, and you could keep this pattern going forever. Now, when it comes to transformations, amplitude, exactly the same. Phase shift, moving it left or right, exactly the same. Vertical displacement, exactly the same. The only thing that's different is the idea of what goes in that B position and the formula that goes with it. Before, we always did that period was 360 divided by B. That's because with a sine or a cos wave, it took 360 degrees to do one wave or one cycle. However, one cycle in tan only takes 180 degrees. If you look, one asymptote is at 90, the next asymptote is at 270. That's a distance of 180 degrees. So your period would be 180 over B. So rather than 360 over B, you do 180 over B. So that really is the only difference. Okay, so what if we have to do, and I need to do this in a different color, so we'll stick with Christmas, red and green. I know it's not Christmas yet, but y is equal to cotangent x. That is the reciprocal. So we're going to follow those same reciprocal rules that we've done before. So wherever the graph is at 0, you have an asymptote. So the graph is 0 at 0. So for cotangent, there's an asymptote. Here at 180, it's at 0. So we have an asymptote. Here at 360, it's at 0. So cotangent has an asymptote. Now, the reciprocal of an asymptote is actually 0, because an asymptote is 1 over 0, because you can't have 0 on the bottom of a fraction. That's an asymptote. So the reciprocal of an asymptote is 0 over 1, which is just 0. So the reciprocal of an asymptote is 0. So here for tan at 90 was an asymptote. For cotangent, it's 0. Here at 270, for tan, there was an asymptote. So for cotangent, it's a 0. Wherever the graph was at 1, the reciprocal is also 1. So that's an invariant point. Same thing with negative 1. So that's an invariant point, and that's an invariant point, and that's an invariant point. Wherever the graph is at 1 or negative 1, there's an invariant point. Now, the graph has to go in the opposite direction. So here between 0 and 90, the graph is going up. So the reciprocal is simply going to go in the opposite direction. So between the 90 and the 180, the red graph is going down towards the left, so it's going to go down in the opposite direction. So same thing here. It's going to go up this way and it's going to go down this way. So it's the same shape, it's just going the opposite way. So there's a lot of colors on there and it's confusing, but that is how you would achieve it. Again, we're not going to do a whole lot of graphing with this. So you have just seen all the other graphs, and that actually brings us to the end of chapter 4. And I finally finished all the videos for it. Yay!